So hello everyone, today we are moving into unit 2 of our data engineering course. Now that we understand the basic data processing and storage framework, we are going to look at the practical technology used to handle the big data. HDFS, that is nothing but Hadoop distributed file systems and the file systems. So think of this, for example, think of this as a moving from learning the theory of logistics to touristing the massive fully automated Amazon fulfillment network to see how the thousands of computers work together as a one team. So HDFS stands for the Hadoop Distributed File System. It is the specialized storage layer of Hadoop designed to hold the massive volumes of data by breaking your files apart and spreading them across multiple ordinary computers. So it is highly scalable and has excellent fault tolerance. So imagine you have massive book that is 10,000 pages long, but your personal computer hard drive can only hold 100 pages at a time. The HTFS solves by tearing the book into 100-page chapter and distributing those chapters across the classroom of 100 students to hold for you. So the architecture of an HTFS is work using a master-slave architecture consists of two primary node types. One is a name node, another one is a data node. So name node is nothing but the master node. So it does not store the actual field. Instead, it manages the file system directly and stores the metadata. Essentially, a map showing exactly which computer holds which pieces of data. So data node, the workers is the data nodes. These are the actual machine that store the blocks of data and handle the reading and writing of your file. So example, think of the name node as a university head librarian who keeps the master computer catalog. The data nodes are the physical book rows and sleeves where the actual book sits. When the students, the client, wants a book, they ask the librarian for the location and then go straight to the specific cell to read it. The futures of HDFS. So why do we use HDFS? It has key engineering features like fault tolerance through the data replications, making a multiple copies of data blocks across different machines, high scalability and data locality. So data locality means instead of moving massive data across slow network to the computation engine, Hadoop moves the small processing program directly to the machine where the data is already sitting, saving massive amounts of time. For example, if you give a student chapter of your 10,000 page book to hold, what happens if that student gets sick or misses class? To prevent losing the data, the HDFS automatically makes copies of that chapter and give them to two other students. If one machine goes down, the system does not lose a single byte of data. The Hadoop ecosystems overview. So Hadoop is not just a single storage tool. It is an entire ecosystem of open source framework working together to store, process and manage big data. The core platform relies on few major components. One is an HDFS, Yarn, MapReduce. So HDFS stores the foundations where Yarn is nothing but yet another resource negotiations. So the system manager that allocates the RAM and CPU power across the cluster. So the map reduces the processing of framework that breaks calculation tasks into small pieces to run concurrently. So in the example, think of the Hadoop ecosystem as a large factory. HDFS is the warehouse floor where materials stacked. Yarn is factory manager assigning works and machinery to different tasks. Map produces assembly line process where the multiple works assemble different parts of product simultaneously to finish the job fastest. So in order to conclude this section, we wrap up today's section. HDFS provides the reliable, distributed and cost-effective storage baseline required for modern big data operations. By combining the HDFS with the tools like Yarn and MapReduce, the Hadoop ecosystem transforms an ordinary networks of computer into powerful processing powerhouse. Thank you.